Hello and welcome to the Stardog Academy training on Stardog architectures. I'm Al Baker, Vice President of Enterprise Solutions here at Stardog. To let you know a bit more about me, for the past 20 years, I've helped organizations like NASA and top 5 pharmaceutical companies realize their goals of getting the right data to the right people at the right time. Today, I'm going to introduce you to Stardog architectures. In this training session, you will learn how to understand the Stardog deployment options, including single node and cluster deployments, review typical patterns within the Stardog architecture, review architecture design choices, and review the fundamentals of Stardog Cloud and Stardog connectors. Let's get started. This section is about nodes and clustering. Let's get started with looking at the single node. This is likely the first time you'll encounter Stardog, and we'll see this very commonly within a development environment, proof of concept, or test environment. The single node can run on your desktop, a cloud, a single server somewhere that folks are sharing. And we can think about the single node in a few different dimensions. First, considering the scaling factors on the single node, we might ask ourselves, what is the data capacity we're going to load? How much data do we need in this environment? And this might vary if you're doing a proof of concept on a single server and would have a typical server configuration, or if you're going to be setting up your own development environment on, for example, your developer workstation. In either case, following Stardog's recommendation on capacity planning, we can look at how much data we're going to expect to have in this server and then assign the appropriate amount of memory. Now, the key parameters here are very straightforward. We can have a standalone server running as your typical client-server architecture, or Stardog also supports a unit test environment with an embedded server, and that would be typically found within a Java API. Looking a little bit more closely at the single node deployment, we see that the developer can use a variety of applications to interact with their Stardog environment. Things like Stardog Studio, Explore, any other code integrated development environment would all be candidates to connect to Stardog. And we see here that the Stardog server itself can connect to other data sources. There's no reason that the Stardog server can't use a virtual graph, even when considering running in a single node deployment, such as in a developer workstation, or doing a proof of concept. It's still a full server and has a lot of capability. Looking at the cluster environment, we see here that we're moving away from our single node proof of concept or development environment and closer to what we're going to look at for enterprise production environments, where we might be creating stages or having staging environments, setting up test environments, and really putting together an architecture that looks like what the end deployment is going to look like. From a scaling perspective, we're still going to look at available memory, but now we're also going to look at available disk space, since we should be considering this environment for production. Additionally, there will be a number of nodes, the introduction of the load balancer concept, and ideally, some amount of platform automation that goes with this. Now, the key parameters to consider about when putting together your cluster will be the available memory that you're going to assign to each one of the nodes, and the amount of data that's been virtualized versus materialized. And we'll get into other options. This is the baseline cluster. Let's take a look at it in a little bit more detail. So in this diagram, we see that we have our HA load balancer that is front-ending a network here where we have 3 Stardog nodes and 3 Zookeeper nodes. Now the HA load balancer provides a single point of abstraction where Stardog Studio and Stardog Explorer, as well as custom applications, BI SQL endpoints, and other third-party applications can all talk to Stardog as a unified front. And so we do not need to have any of the consuming applications be aware of the details of the cluster environment. They would typically be configured with things like a domain name that represents the load balancer. Now on the bottom end, we have virtual graph, natural language processing, and ETL for our data sources. And these may be connected to Stardog in all forms or fashions. And there is not one correct answer in terms of how much virtual graph or how many documents get NLP'd in, or the type of ETL pipeline. And these will all be very specific to the customer environment and the types of data sources that you might have there. Taking our baseline cluster, we can now look at adding virtual graph caching as a means to further scale the environment. Now, these use cases for when you would start to introduce virtual graph caching will be your larger scale deployments and your larger scale virtual graphs. And we've seen these types of architectures in environments that might have what are typically described as big data components, and looking at how we can start to horizontally add additional resources to the Stardog deployment to gain additional scale. Now, our scaling factors are going to follow in line with what we've previously discussed. However, we're going to look at the size of the virtual graphs as one of the key components here, and the velocity of change of data to understand if we need to have a virtual graph, a cache, or sometimes even both. There are several cache optimization techniques to have, from running a single standalone Stardog node as a cache target to collapsing that cache into the cluster. And altogether, this presents the opportunity for horizontal scaling. Now, our key parameters are going to be a per virtual graph data source volume, understanding how much data we're going to have in that virtual graph data source, the number of cache data sets per node, and how those sources map to cache nodes, and then the configuration of the cluster versus caches, and making the decision on whether data should be loaded into the cluster, where it would gain high availability type capabilities in terms of replication of that data, or running Stardog cache nodes, and how many of those cache nodes we might want. Let's take a look at the Stardog cluster with virtual graphs in a little bit more detail. So like before, we see that all our consuming applications communicate with Stardog via the HA load balancer. For the sake of simplicity on this diagram, we've collapsed the Zookeeper nodes. They're still present in this cluster, but for the sake of the diagram, we're not showing them here. Now, additionally, we have a little bit more detail on the bottom side with the virtual graph, NLP pipeline, and ETL. And the virtual graph node, we can see here as an additional Stardog node in between the virtual graph and that far end connection. And so this means that the abstraction up at the top, where consuming applications like Stardog Studio or Stardog Explorer send a graph query to the Stardog cluster, that query may be part or in total answered by a virtual graph, and that virtual graph may be in part or in total backed by a cache. And this abstraction holds all the way up to the top, so that your application or your query or the thing that you just clicked on in Stardog Explorer does not have any knowledge about the cluster that is running, the virtual graph that got used, or the cache node that might have backed it. Now, there's an additional third-party component shown in this diagram, which is Apache NiFi, something that Stardog provides several processors for. And this would be a typical enterprise deployment where you'd have ETL of perhaps some legacy data sources or data sources that were not agreeable to virtualization, combined with a larger number of virtual graph sources, some of which may be cached, and then addressing the unstructured data in enterprise through one of the NLP pipelines. Now, what happens when we have a cluster with a virtual graph cache and expand that to many caches? Well, there are no restrictions in Stardog on the number of cache nodes that we can deploy. And even if we want to have those cache nodes front end many of our virtual graph data sources. Now, in this diagram here, for the sake of simplicity, we've dropped things like the NLP pipeline and the ETL input. And we're just going to look at the virtual graph connections. And so here we see something interesting where we have multiple other nodes being front-ended by Stardog cache nodes. And then on the bottom right, we have just a standalone Stardog. And so what this is representing is that we do have the option in our building our architectures where we can have Stardog virtualize another Stardog instance. And this is not in terms of a virtual graph cache, but just a virtual graph connection between Stardogs. And as we'll see shortly, that's going to open up many opportunities for us in defining different types of architectures for other types of enterprise challenges. Now, taking that existing diagram and adding in our third-party components and other key capabilities, we see that the ecosystem of a Stardog enterprise deployment has multiple touch points with the IT ecosystem that it lives in. Now, up at the top here, at the consuming layer, we see we have Stardog Studio, Stardog Explorer, custom applications, the BI SQL endpoints, machine learning, automated reports, and other third-party integrations. And those all take advantage of a single point of abstraction through the HA load balancer as commonplace in all cluster deployments. Now, in addition to that, likely the HA load balancer is where we'll introduce some form of enterprise security and do things like configure SSL certificates and things of that nature. In our Stardog cluster, please note that Zookeeper is not shown but is still present. However, there are a number of other third-party capabilities that we are going to configure with our cluster. Starting on the left, ontology management, perhaps via Stardog Studio or third-party application, can be used to manage which ontologies and which named graphs are in scope in the Stardog cluster itself. Continuous integration or continuous delivery applications can be configured to deploy clusters or expand cluster nodes or cluster membership, as well as interact with cache nodes and providing some amount of scaling out the cluster as deployment options become apparent. This also can all run on Kubernetes containers in a Kubernetes environment and have specific customer workflows for deploying data, updating virtual graph definitions, turning things into caches or taking them out of the caches, and so on. We've also introduced the concept of a data catalog here, which can be an excellent source for pulling schema information to create a virtual graph. On the NLP pipeline side, we've noted that there are partner products that can be integrated to provide vertical-specific NLP solutions for different types of unstructured data that might have specific characteristics present in that vertical. A good example of that is life sciences and pharmacology. Now, on the right-hand side of the cluster, we see things like log watch or log rotating for pulling logs off the cluster. And typically, once the logs are off, we can set up monitoring and alerting for specific events or thresholds that we care about. For those interested in learning more, you can please check out our performance-based training, which will go into more about the different types of monitoring and metrics that will be of interest for Stardog clusters. Additionally, we'll have backup and restore as a workflow that can be applied to the cluster. And depending on your cloud environment, there can be some optimizations here for storing backups to cloud-based file services. On the ETL side, we can have an enterprise service bus or the enterprise integration architecture patterns be hooked up and participate in an enterprise IT ecosystem. As the before-mentioned Apache NiFi shows, we can use that as a third-party product for managing our ETL workflows within this ecosystem. This concludes the section on Stardog nodes and clustering. This section is about Stardog Cloud. Now, looking at Stardog Cloud, we have a managed service offering where we can take advantage of a fully cloud-native deployment managed by Stardog and working with the customer to address their deployment considerations. Now, like other environments, we can consider the size of virtual machines, the number of the Stardog nodes, and virtual graph connections that we're going to deploy. However, there are some other key parameters that are specific to Stardog Cloud to take into consideration. First will be the virtual memory and disk configuration, as well as the hybrid cloud connections on, is this going to be in a heterogeneous cloud environment or combined with some form of on-prem Stardog installation. Looking at this a little bit further, we can see here a type of hybrid cloud environment deployment where we have Stardog running in the AWS cloud, Stardog running in the Azure cloud, and all working with an on-prem solution where different data repositories are in each environment and virtualization has been set up as a mesh between each of the different types of nodes. Now, it is important that this type of hybrid cloud environment, as depicted on the screen, will be relatively unlikely, as many customers will likely prefer one major cloud provider such as AWS or Azure. However, the unification of data that is present in both the cloud and in the on-prem environment is going to be more commonplace, and we can take advantage of things like the virtualization such that the Stardog running in the cloud and a Stardog running on-prem can communicate with each other. Moving on to other types of Stardog deployments, we can look at a fully distributed Stardog where we take this idea of virtualizing other Stardog instances and taking it to the next level. Now, these use cases are going to be a lot more vertical solution specific and have their own challenges in terms of rolling out production deployments and configuration management of the network. However, Stardog's capabilities, especially on virtualization and other key aspects of data management within Stardog, mean that we have a high degree of capability to deploy a number of network topologies that might not otherwise be possible in traditional architectures. And this means we can handle things like mesh environments or connecting typical data centers to networks of sensors or sensor meshes, IoT capabilities, and the like. Now, from the scaling perspective, this is going to introduce some other concepts like geo-redundancy requirements, identifying the network topology that the Stardog is going to be deployed in, and understand how we're going to manage data in this highly distributed environment. Our key parameters for deciding to use this type of architecture will be the number of clusters, as well as the number of data sources per cluster, and the network configuration that we're going to need to set up this type of architecture. Looking at this in more detail, we can see Stardog virtualizing itself in a complex enterprise, fully distributed environment. And so a use case like this might be something along the lines of supply chain, aerospace or defense, or other cases where you have regional systems, typically in a data center or a cloud environment, and then individual platforms, such as a sensor platform, an IoT device, or other capability, where we can take advantage of all the before-mentioned features discussed in this presentation to provide a robust architecture. The sensor mesh itself could have point-to-point virtualization, and the Stardogs there could virtualize each other as appropriate to meet mission requirements. The regional systems themselves can be full Stardog clusters with virtual graph definitions to the other system. And in the case of geo-redundancy, a specific capability can be deployed where Region A systems and Region B systems can be kept in sync. This concludes the section on Stardog Cloud. This section is about Stardog connectors. In all the architectures we've looked at so far, we've seen many of them have virtual graph connections or otherwise have connections to different data sources. Now, Stardog provides a large variety of these in a virtual graph configuration. And these include things like relational NoSQL data sources, cloud service integrations, certified BI SQL connections, where Stardog provides a MySQL driver wire compatible environment for connecting a BI or SQL endpoint to Stardog, as well as various programming languages and SDKs that can be supported. Fully combined, this gives us a variety of options to choose on the best way to take advantage of Stardog in an IT ecosystem. From looking at how we virtualize or load existing data sources, take legacy applications and migrate them to Stardog using things like the BI SQL connector, and then take advantage of graph-specific functionality and build new applications, extensions, or customizations to other ecosystem components such as portals, web parts, and so on that take advantage of the graph-native features within their target environments. This concludes the section on Stardog connectors. This section is about development and production. Now, regardless of what Stardog architecture you're going to deploy, from the single node all the way to the clusters to a fully distributed environment, there is a separation of concerns that we like to look at into different deployment tiers. Now, this is not going to be specific to Stardog, but is highly recommended in any type of system where we're managing both the system, the applications connected to it, as well as the data that gets loaded into that system. Now, a common example would be a 4-tier environment where we have our top-line production, highly controlled, and configuration managed. A staging environment that matches that, where staging actions such as loading data, doing a test run of virtualization, or overall system verification and pre-production deployment staging can happen. Now, having a common test environment as our third step down here is also very common. Now, the test environment may have other data sources that do not quite match the staging or production data sources, but are representative enough to perform a test. A good example of this is we're not going to have typically 3 different full copies of a data lake that Stardog is virtualizing, one in production, then a staging data lake, and then a test data lake. However, that connection type is likely going to be present in all 3, and the test one likely has some representative data set that can prove out that the deployment and moving to staging will be successful. And then last but not least, on our 4th item in our hierarchy here, we have the development environment. And if we look all the way back to the beginning of this training where we talked about the single node deployments, this could be anything from running Stardog Cloud to a shared server to Stardog on our development workstations. And so our considerations are going to be, how do we want to share development environments? Is this something where the team can coordinate across a shared resource and take advantage of things like Stardog's multiple database support and permissions as a means to not step on each other's work? And then also, how do we make representative data in those different environments? In many cases, some of the data that's going to be virtualized or loaded into Stardog will be significant in size and not something that we can easily load into a development environment, or in some cases, even a test environment. And so putting together a representative data set is one of the key considerations on how we set up our multiple tier deployment environment. This concludes the section on development and production. This concludes the Stardog Academy training on architectures, where we learned how to understand Stardog deployment options, including single node and cluster deployments, review typical patterns within Stardog architectures, review architecture design choices, and review the fundamentals of Stardog Cloud and Stardog connectors. Thank you for following along. If you have any questions, please review our frequently asked question page or head over to docs.stardog.com for additional information.